So good morning, everyone. I think we can get started now. Thanks for joining me. My name is David Zanchetta, and some of you may have heard my presentations in the past about RC swivels, vertical travel leads, and excavator mounted leads. Today, we're going to talk about lead system technology with an odd name, and that is flying leads. So before we get started, both myself, David, and my colleague Stefano will be speaking in today's presentation. If you'd like to reach either of us for any reason in the future, I suggest adding our contact cards to your phones. Steph covers Europe and South America. I cover Eastern Canada and a little bit in the United States, but I can direct you to any of your salespeople that would cover your area. So if you do have any questions during the presentation, you can type them into the chat. My colleague Milan is going to keep record of them and ask them at the end. We should have about 5 to 10 minutes at the end of the planned content for questions. So we're going to go through the agenda here. What is a flying lead? Isn't it just a hanging lead? What components turn a hanging lead into a flying lead? Because it isn't just a hanging lead. And then we're going to look at types of leads and box versus spud. We're going to take a look at the leads Berminghammer offers and talk about which ones can be put into a flying lead configuration. And then we're going to use some example jobs to explain why flying leads are used and what tools they are used with. So Berminghammer is known to have made one of the best innovations in lead systems, which is the vertical travel lead. So why am I presenting today about flying leads? It's because flying leads are especially useful in several situations, and I'm going to explain those throughout today's presentation. So first thing we're going to start off with, what is a hanging lead? So you can see the hanging lead in diagram form on the left. There's a little video showing the lead being held by a crane and a hammer driving a pile. Now, a hanging lead situation, typically you have the crane drum 1 holding the lead. You have a second crane drum holding a tool, and then you have a third crane drum holding a pile. The advantages to using a hanging lead is that you can lay these leads down and use your crane for regular lifts again. The con in most situations is you need a third drum in your crane, which is hard to find sometimes in rental situations. So a flying lead is a hanging lead with a built-in drum. So you can see in this photo, and I'll use my laser pointer, that there is a winch at the bottom here and a line that goes up and over the top of the lead and comes back and holds, in this case, a drill. So the pro is that you eliminate the need for a third drum in the crane, yet you still have the advantages of a hanging lead in terms of being able to lay down your lead and disconnect from the crane entirely. So in this case, your crane drum 1 holds the lead, but then your lead drum 1 right here holds the tool. And there's also situations where you can add an optional second line to hold the pile. So you could add another drum down here to hold the pile. So component differences, hanging versus flying. The main difference between a hanging lead and a flying lead can be shown in this slide by side-by-side comparison. So the hanging system's on the left, the flying lead system is on the right. So the left shows a hanging lead system complete with lead sections and a taper top that guides the two crane lines. One of the crane lines that holds the lead and the other that holds the tool. On the right side, the same lead column becomes a flying lead with the addition of an extended head shiv up at the top here and a winch right here. So once you have those two components, you become a flying lead. But in order to make sure that the winch doesn't get buried in the ground when you're horizontal, we add these things called standoff frames, which are just little frames that help elevate the lead off the ground so that the winch, when the lead is on its side, isn't buried into the ground. So again, this slide just shows the flying lead components just with the context of a photo instead of a diagram. So here we have the photo of the lead showing the head shiv, the tool winch, and the standoff frames. I wanted to add this slide to show the scale of the extended head shiv. These are some of our welders standing with it in our assembly shop. This is the second largest extended head shiv that we make for our spud leads. There are larger extended head shivs that go with our box leads. Just gives you an idea of how large these pieces can be. This is for the H28 lead, and I'll explain a little bit more about the different lead sections shortly. So what lead types can be converted to flying leads? The short answer is that any lead that Berminghammer manufactures can be converted into a flying lead. So if you already have a vertical travel lead from us, you can convert that lead by adding a head shiv, winches, standoff frames to becoming a flying lead. So the type of lead that you would typically select comes down to the length of lead that you need and whether or not you need high torque resistance. So as I said in the previous slide, any of the leads in our catalog can be converted into flying leads. There are a couple key factors influencing which lead column you would use. The first is depth, and the second is torque. On this slide, I'm going to focus on depth. So you can see I have circled the depth measurement on each of these lead columns. So the left here is we call our L series. It's a spud lead. And the reason it's called an L is because there's an angle iron in the corner. And our H leads has a hollow structural section in the corner, hence the H. The box leads aren't named after anything like that. They're actually just named after their width. So BL42 is the 42-inch width here, and 57 is the 57-inch width here. So why is the depth important? Essentially, it determines how long of a lead column you can have. So I just brought in the same picture of a lead column that was in the previous slides horizontally. So you can imagine if you have just like a bridge girder, if you have a really deep bridge girder, you can have a much longer span on your bridge. So you'll notice that the L18s are 18 inches deep, L23s 23 inches deep, and you can make your way up to see all the different depths. So the depths are essentially increasing from left to right on this chart. So with your L systems, the longest you're typically going to make a flying lead system would be about 80 feet. When you get deeper, 25, 28, 36 inches, so 36 inches allows you to get a lot longer, to about 150 feet. And if you want to go very, very long, you can take advantage of the additional depth of the box leads, which can be 45 or 51 inches in our current catalog state. So you can get up to about 200 feet. The second thing I'm going to highlight is the torque. Note that if you have a hammer, no torque is needed. So when you're sizing a lead for a hammer, typically you're just looking at the weight of that hammer and the length of the lead that you need to pair correctly. But if you do need torque, this slide will help you understand kind of which leads make sense. And some leads have clear advantages over others. So the leads that we have essentially allocated to being piling leads still can withstand about 45,000 to 65,000 foot-pounds of torque, depending which one you have, the L18 or the L23. And we've been pairing those traditionally with a drill, historically our BHD 40, but now our current model drill is a BRC 32 or 35. So 35,000 foot-pounds of torque would go with these two lead columns. We've been drilling in flying lead situations up to about 24-inch with this setup. So as you hop further to the right on this chart, you can see the H25, H28, and H36 have quite higher torque values. So 200,000 foot-pounds, 250,000 foot-pounds, 350,000 foot-pounds. We've been pairing these lead columns most often with our reverse circulation drilling drill, which is the BRC 200. Now, the box leads, you can go very long, but they're a little bit less torque than these H spud leads, right? You have about 80,000 foot-pounds, 150,000 foot-pounds. So we have been pairing those with our BRC 100. And you can do really, really long piles up to about 36, 40 inches. Somewhere in around there is where kind of you would, the torque matches and is a eloquent system. So the next slide, I'm going to go over the advantages of the flying leads. The first one is that you can lay it back down and use your crane for other things. And I want to overemphasize that. So you can lay it back down, take it off the hook, put it back down, do other operations, come back to it, pick it up, and drill or drive again. So another advantage is you can reach further than if you're using a fixed lead setup. Most of the time you can reach further. This is because in a fixed lead setup, your spotter is typically so long. And if you go with a flying lead instead, you just have a suspended load. It's an easy calculation to figure out how far you can reach with your crane based on your crane chart. A third advantage is you don't have to rent or provide a three drum crane, which can be really hard to find in certain areas. And if you want to rent a three drum crane in certain, they can often charge a premium for it. You don't have to do that. And again, you can switch between different cranes easily. So if you had two cranes on a project and sometimes you needed to do foundation elements for one, and then sometimes you need to do foundation elements with another, you could switch the lead between the multiple cranes. So next part of the presentation, we're going to go over some example projects. Primarily, we've run hammers, impact hammers and reverse circulation drills with our flying leads, but you could have other applications as well. The first job that I'm going to go over is an RC, stands for reverse circulation drilling project that was in Sault Ste. Marie, Michigan. Some people might know that this is where Lake Superior heads into Lake Huron, and there's a change in elevation, so there's some locks at that location. And in improving and creating a new lock at that location, my customer was challenged with installing by reverse circulation and case advanced methods some 48-inch pipe piles socketed into rock in case advanced. So on the left photo, you can see how they did most of the project. They had a barge, HC 275 crane, and a flying lead. This flying lead in this case was connected to the crane with a spotter. We call that a semi-fixed configuration. And they did that to have more control over it for the majority of their project, installing the majority of the piles. But there were 4 piles on this project that were just in a completely different location that they couldn't reach with the barge and crane combination. So you can see a completely different crane lifted up the flying lead and accomplished drilling in those 4 piles. So this project essentially hit all the advantages of flying lead. So they laid the lead back down and used the crane for other things. In the case of the middle photo, you can reach further than if you were using a fixed lead setup. I believe this was in the neighborhood of 60 to 65 feet from center pin, a lot further than they were reaching here. And you don't have to rent or provide a 3-drum crane. Neither of these were 3-drum cranes, and you could switch between cranes easily. You can see completely different cranes, same lead. So another example of a flying lead is this RC drilling project in Hawaii. This is an example of a project where we did a flying lead with 2 drums. You can see on the back of this diagram, this lead, we got 1 drum here, 1 drum here. They both go over the extended head sheave, and one holds the drill and one holds the pile. In this case, they do this because you want to hold the pile and help interlock it into the main bit. You have a ring bit. It's a reverse circulation case advanced drilling technique where you're locking into your pilot bit and then advancing the casing right into the rock. In this case, the customer in Hawaii wanted to use the same crane to do the foundation elements as we're going to do the rest of the lifts on this bridge project. So we brought in the flying lead, and in this video, you can see them drilling in the pile. And then they could lay the lead down and continue to do the rest of the lifts on the project with the same crane. Now, again, it's taking advantage of the same things. You can lay your lead back down and use your crane for other things. That's the big one on this one. You can reach further than if you're using a fixed setup. I think this was about 55 feet. You don't have to rent or provide a 3-drum crane. The next slide, we're going to go over some hammer applications in New Orleans on bridle leads. Now, bridle leads are a large enough topic to have their own presentation. I thought I would just touch on them here. These photos are taken from various projects in Louisiana working on levees. The levees in this area are typically composed of very long H-piles driven in on very aggressive batters. The piles are so long and the batters are so aggressive. Think batters like 3-to-1, 2-to-1, 1-to-1, that vertical travel leads become impractical to use. Hence, the flying leads are set at a batter using the bridle. So the bridle leads are essentially just flying leads set on an angle. So you can see here that at the bottom of this bridle lead, we have a winch. We have our extended head sheave. Standoff frames essentially come in these hanger bars, but attached to those hanger bars are the bridle system. So again, a flying lead is just a bridle lead is just a flying lead set on a batter. You have all the same advantages we've previously talked about, but you have the addition with a bridle system of these extreme batters and extreme length. It's at this point of the presentation that I am going to turn the mic over to my colleague Stefano. I'm hoping that I can make sure that his mic's there and I can highlight him for you.
Good day, everyone. Thank you, David. My name is Stefano Gabaldo. I take care of the international sales for Berminghammer. And I wanted to highlight a couple of very, very successful projects that highlight the versatility of a flying lead once customized to a project. So the lead is already a very precise alignment tool. But the methodology that we choose on the usage of the lead allows us to add customization of the lead itself in order to achieve higher productivity and higher accuracy. This slide shows a typical port that you may have seen around the world. This is a Kingston container terminal expansion. Basically, they wanted to bring bigger ships. Bigger ships means a bigger draft. When you bring bigger drafts, you need to have dredging. And the moment that you add dredging in front of an existing structure, you're required to put in some sort of a buffer construction in order to separate the existing soil elevation with the new dredge seabed elevation. So if we go on to the next slide, you see that the construction is actually shown, the existing construction is shown in pink and gray. So that was our existing port. The port is perfectly fine the way it is. They just needed to dredge. So we needed to introduce, in this case, was a pipe-to-pipe wall of 558 millimeters, so 22 inches roughly, 14 meters, 15 meters in length maximum. So it wasn't a big pile. The challenge was that it was interlocked. And the interlocked requires us to put in precision in the placement on the next piles. So the accuracy required in this case was 6 millimeters. We were on top of the dock, so there were the difference between probably 15 to 17 meters between the deck elevation to the existing seabed elevation. At that distance, we were required to remain within 6 millimeters of accuracy. So we decided about different way of doing this. We decided looking at different templates, maybe to have a VTL system that had a very downwards bias. And we decided instead of a flying lead with a very customized, modified foot. Basically, we engaged the last two driven piles to give us the exact location of the next pile so that the interlock was always guaranteed. In this particular project, we had to drive 1,200 piles. All of these were mechanically interlocked without any use of divers or any use of marine equipment. The next slide shows pretty much what the system was all about. We had a long lead that we lowered all the way down to the previously finished pile, and it relied on a template that basically was moved along the dock by the theoretical distance of the center to center of the piles. The verticality of the lead then will give us an exact feedback of the direction of the wall that we were constructing on the seabed, and we had steering mechanism to allow to maintain this wall perfectly aligned with the existing dock wall. This system ended up being so accurate that now we can use it with combi wall construction. So we can actually do pipe piles, king size piles, and then we put in double sheet piles between them. The next project is is actually another project that highlights very much the ability of the flying lead to give flexibility to the construction methodology. Here we are on a jetty, and we're constructing it requiring the usage of only one crane. There is no room for anything else. And we wanted to separate the land equipment, and we wanted to actually get rid of the land equipment so we were not subject to sea conditions. So we had a country travel system that basically positioned the template for the piles. The methodology was very simple, and we used this many times over different projects, which is drive the pile, clean the pile, and then rock socket the pile. In this case, the pile was a meter in diameter. We drove it to the seabed and down to rock. Then we use an RC auger. Basically, it is a little bit of an invention that we did out of a necessity within our construction company in order to avoid the in and out when you clean a pile with either a bucket or a bower rig. So basically, you go in, you use the reverse circulation, and you keep on augering until the pile is clean. Then we would rotate the crane to the back, drop the RC auger, and drop the RC auger, slide over the downhole hammer, pick up the downhole hammer, go back into the hole, and perform the 6-meter reverse circulation. This system ended up being twice as productive as your typical marine equipment that you find on barges. And it basically allows the crane to do both the drilling equipment and, when finished, laying down the lead, like it shows in this slide, and perform all the superstructure construction. So basically lay the reinforcing steel, pump the concrete, and all the different placing the pile top cups. So all of this is allowed because now the lead, the crane is just a lifting crane. It's not the drilling rig. Like David was saying, this allows you to have the flexibility of bringing the crane to do it. It becomes a drilling rig. Once you're done the drilling, you lay it down, and now you use the crane to do all the other lifting, performing all the lifting methods.
Thanks, Stefano. And I'll just reiterate, the flying lead is a hanging lead with a built-in drum and a head sheaves. And why do you have it? It's so you can lay down and lift again, so that you can reach far, and so that you can use a 2-drum crane and switch between cranes. So that actually takes us to the end of our planned content. And one of the things we like to do at the end of every presentation is ask you to rate our presentation in the chat by a score of 1 to 3. The chat is at the top. It's a little chat bubble. If you click on it and go and could enter this for me, I'd really appreciate it. 1 would be that you had no value in this presentation. We shouldn't do it again. 2 is you learn something new that you might use one day. 3 is you learn something that makes a lot of sense to implement. So 1 to 3 would be very much appreciated. I will mention that on March 20th, we're going to do another presentation similar to this about our reverse circulation drills. If you would like to sign up for that one, there's a QR code on the screen right now to be able to sign up for that one. I didn't see any questions in the chat, but if there are any, feel free to either raise your hand. There's a raise your hand item, or unmute yourself and ask some questions. I'm sure there's some questions, and if you don't want to unmute yourself, you could always ask them in the chat as well. I'm taking a look at the chat right now to see if there's anything. And while we wait for people to think of their questions, again, if you would like to contact Stefano and I, our contact cards are up on the screen again. I don't see any questions. Oh, here we go. Got one. How do you handle massive torque? I'm assuming you're talking about the, maybe I'll back up a couple slides. So we've got a drill like this one, and you're talking how do we handle the torque of the lead going on to from the pile. Is that kind of the thought process there?
Yep, correct.
We have several ways of doing this. In this case, we actually use a clamp. So the pile was driven, so we had enough torque reaction from the soil given by the driving of the pile to top of rock. If that is not enough, so typically we just clamp the pile, we react against the torque of the drill on the stiffness of the pile and the ability of the pile not to rotate. If that ability is not enough to fulfill the full amount of torque that we put on the drill, then we have, if you see at the very bottom, there is a little bar that goes, a yellow bar at the very bottom of the lead that basically goes inside a template fixture in order to increase these torque capabilities. So our lead typically have both. We typically like to rely on the stiffness of the pile. If that is not enough, then we just engage the template in order to react against this torque. Also to add, if you were in casing advancing system, we cannot clamp the pile, so we would need to react against the template itself.
Yeah, you can see in this photo as well, they've got a template and it consists of essentially a I-beam sideways that the foot then is inserted in. And this was our BRC 100 on that one. So it was a template that the foot was inserted into to hold the torque. It's another example. Don't know if the previous one shows it. In this case, again, it was a template that was holding it, holding the foot of the lead. But when I say foot, I just mean the bottom of the lead. And we typically make something that you can lock in so that it won't spin.
Thank you.
No problem. I do see that. Yeah, I do see another question. How do you handle the deviation of drill string for 200-foot CFA depth in advantage in comparison to traditional drilling rigs? I don't fully understand this question in the context of this presentation, but in terms of handling deep CFA, how do we handle the deviation of the auger? I think, is that the question, Fabian?
Yes, correct. That's the question I have.
Okay. Traditionally, we have a number, depending on the length of the lead, we have a number of what we call tool following gates. Those gates are suspended from the head shifts at the top of the lead on one end and essentially follow down the lead so that they can brace the auger at 2 or 3 points that are always slowly decreasing down till they're right at the bottom of the lead. I don't know, Steph, if you wanted to add anything to that.
Yes, and you also mean, I mean, it's a great question actually, because 200 feet of CFA, it's certainly a challenge. So while the auger itself is on the lead, we can put provisions in order to maintain the alignment of the lead and the auger. Once we are into the ground, there it becomes a little bit more challenging, and the driller experience comes into play. So there are a lot of ways to minimize any deviation due to ground conditions. One is to minimize the crowd that you put onto your auger as you go down. And sometimes if your verticality becomes crucial, it's the speed in which you will advance the auger will become a little bit slower, because you want to play a little bit more importance on the verticality that you want to achieve instead of the production that you can achieve with the system. So I think at the bottom line, it's once the auger is into Mother Earth, Mother Earth a lot of the time dictates what happened next. In order to avoid that is to be very, very careful in the speed in which you advance the system. Typically, when you go very large, very long CFA, you also have significant diameter, which allows us to have a certain stiffness. The stiffness helps us in maintaining verticality. And but typically when you go down, there is several techniques that you can use in order to maintain the verticality of the column. I hope this answered what you were asking.
Thank you, Stefano. Yes, that helps me. Thanks.
Yeah, I was thinking while Stefano was talking, we have tool following gates as well as swing away gates. And the type of swing away gate has been used in CFA as well. You would just have 2 or 3 gates that open up away from the tool and allow the tool to pass through. So that's another way that we have retained the column of continuous flight auger. There was another comment that said it doesn't appear that flying lead systems have mechanical crowd force. Most of the ones that we showed in this presentation don't, but we have done crowd force in the past. Most of the time when we have been using these for reverse circulation drilling, we have been using down the hole hammers, which don't require the crowd force. But there have been some applications when we've been using full-faced bits where you have needed crowd, and we have done that in the past. Kyle, I could show you some examples. Steph, I'm thinking about the SETDL project where we apply
Yeah,
crowd
so
force.
there is, yeah, so on RC drilling, so you have big face drill bits. What you typically want to do, you want to have some collar weights. So you'll have on top of your large diameter bit, you will have some mass that will help to give you some extra pressure on the roller bits that you have on the bit. Another way that we can do, if it is a rock socket, for instance, on a long pile, and with our clamp in the pile, we can exert an upward pressure for the capacity of the pile itself. So if this pile were to be pre-driven by an impact hammer, and then we go in and clean it, and then we go and do the rock socket below that it doesn't require downhole hammer, and you want to do it with a standard RC rotary drill, we can apply, without having extra weight, we can apply the same force as the ability of the pile itself to resist tension. Another way of doing it is that if I don't have this force available, I can always react against either the template, a barge, or a dock, or whatever land-based items that assures me enough reaction in order to apply the crowd system. So the system in themselves, they can only crowd without any additional item. They can only crowd on the self weight. But if we clamp it or we lock onto a fixture that is connected to either the template or land, we can exert a much higher crowd force.
Kim Coffee asked, are you powering these winches from auxiliaries on the crane? And I think I can answer that one, as most of the time it is system specific. Some cranes have the auxiliary functions to be able to run these. Some of the really duty cycle cranes that are out there on the market can run all of these functions without any additional power pack. In quite a few cases that we're providing rental systems, what we'll do is we'll use a power pack that we have that already has built-in valve banks and controls to be able to run all of these. And typically we are mounting that on a power pack bracket on the reverse side of the crane. I don't know if Stefano, you wanted to add anything else to that?
No, I think you covered it. There are some, typically your duty cycle crane has a much higher hydraulic capabilities than lift cranes. So within reason, I think we could use, and we've done it before, we can use the capacity of the duty cycle crane to supply the hydraulic power. Most of the times, our clients have actually lift cranes, in which case we actually either we use an existing power pack from the client itself, and we can just mount it nearby, or we provide support power pack bracket for the cranes so they move in unison, or we can figure out exactly, or we can supply actually the power pack if required. All of this typically goes through what we call a standalone valve unit. What this does, takes the power out of a power pack and distributes it according to software and valves to the various circuits, whether it is a drill, a gate, a hydraulic clamp, or a winch. We distribute the right pressure and flow to each of these services. So all you need to do is to either have a crane that has enough hydraulic, or put in a power pack that has, according to our specification, to supply this hydraulic box that we supply, that has all the controls for all the services that the lead contains.
Kim, does that answer your question? Awesome. I like the thumbs up.
Perfect.
Maybe we'll wait another minute, see if any other questions come in. But guys, thank you very much for the questions that were asked. We do very much appreciate it. And thank you for answering the 1, 2, 3 question.
Well, I think.
All right. Yeah, let's sign off, and thank you everyone for attending. I will make a version of this presentation available online in the next couple of days. If you just follow on LinkedIn the Berminghammer account, you could share this presentation with a colleague or something that you think might want to see it. Talk to you later.
And if you have any further questions or things, you can always contact David and myself, and we can deal in more depth in a specific project that you might have, or carry on the conversation. Thank you for your attendance and your time. Very appreciated.
Bye, everybody.
And see you next time.